you guys are able to see my screen, right?
Yes.
Okay. So have you get a chance to create Snowflake pre-tier account? Anyone having any issues while creating free Snowflake account? Please let me know so that I'll or some people they will call it as public and information schema. Okay, so here you may get two interview questions. So when the moment you create a Snowflake account, by default, which role it will be? That will be a system admin default role. So total, how many roles are there? Total 5 roles. Account admin, system admin, public, security admin, user admin. Okay, default is system admin. Okay, if you having access, then only you can able to view these roles. Remember that when the moment you go click on drop down and click to switch role, if you are not finding anything, which means you don't have access or permissions. Okay, if you are able to view only account admin or few out of 5, you can able to view 2 or 3, which means you are only permitted or granted permissions to those role only. Okay, and if you want, which is the edition which we chosen, so this is the edition and the cloud platform, which cloud platform we selected, AWS or Azure or GCP, and the region. So every information you will get it here in the drop down. Clear? So let's see, we'll create a table. Create or replace table. This is the keyword. This is fixed. Okay. So or replace I have specified, right? So this is something like I'll show you what is the difference. Create a table. Table name. I'm making EMP. Table name is EMP. This braces we will call it as open parenthesis. This is open parenthesis. This is close parenthesis. Don't call bracket. Okay, open parenthesis. Then I'm trying to creating a table. So when we are trying to creating a table, so we need the column names, right? So table is nothing but a combination of rows and columns. So here we are creating a table by using the keyword called create table is keyword. So here EMP is table name. So whichever the name you are comfortable, you can make it here. So you can make it your name also. There is no restriction on here. Okay. So I'm making EMP ID. So employee ID, it should come always in a number, right? It will not come in a character format. So this is also is not fixed. Few organizations, they will follow with the number and character format. Okay. I'm making EMP ID as a number and name. So name, it will be always characters, right? So I'm specifying a string. So for time being, I'm taking 2 column names only. Okay. So here, if I select the complete 5 lines and if I click on run, then it will run the complete thing. Okay. So if you use this semicolon and if you place the cursor anywhere, any place here, and if I run it, then the complete statement will take it automatically. Okay. This semicolon indicates saying that this statement is ended successfully. Clear? And if I want to recreate the table name, then if I execute it, then it will say that error, SQL compilation error. The table is already exist. Okay. So that's why here we add or replace. Now if I run this select this statement, then it will allow us to create a table. Okay. If we create a number of times, the table creation will be one time only. It will not create a uh, multiple times table. It will create a single time only. So here the database which we have chosen is DemoDB. So in the left side, if I expand it and expand the public, because here the schema is public, so I'm expanding public. So here table is EMP, correct? So now the table is created, but we have not inserted any data, right? So to insert the data, we have to use insert statement. Insert. I'm not uploading. I'm just trying setting a record via statements. Okay. Values here. Employee ID is I'm making 1001 and name is string. Right? So string always recommend to maintain in a single quotation. For number, we no need to maintain the quotation. For characters, we have to maintain in quotations. Okay. Is for one record. If you want to add more records, then what you can do is just use comma. Okay, I'm adding another record, Alex. Okay, so if I use a semicolon, no need to select the entire line. Okay, so if I don't use the semicolon, then I have to select the complete sentence and I have run it. Okay. So here I have inserted successfully 3 records. So here the number of rows is 1 and the number of rows inserted is 3 records. 3 records we have inserted into EMP table. So now we will see the data. So this data will be stored in data storage layer. So now if you want to view this data, so then we have to write select statement. Select, which means we are selecting the column names, which column names we want to view it from the table. Okay, select column names. So we can simply write a select star from EMP, but this statement is not at all recommendable. Star is always create a problem. Okay, and the performance wise also it is not recommendable to use star. Even in traditional all databases also star is not recommendable. Even in Snowflake also star is not recommendable. Okay, so it is always a best practice to make column names, which column names you want to look at. Now we are looking for the column names employee ID, which means we are selecting select employee ID comma name from EMP. Okay, I'm executing So did you observe the issue? If I select the complete line, 12 line, and if I run this statement, you will not get the error message. So this is how the look and feel of the data it will be. So we having two columns only, employee ID and name. This is how we will look into it. Okay. In case if I didn't select the complete line and I'm just placing a cursor here, and if I click on run, then you will get error message, because earlier sentence it is not completed. So system understand that this statement, it seems it's not completed. If I add a semicolon here, then the system will understand that this insert statement is completed, and this is the fresh one. Okay, if I select and if I execute it, then it will work. Clear? Any doubts here? About creation of table, inserting a data, and how and what basis we are getting the column names and we are viewing it. Okay, so we'll discuss it once again. So here we are creating a table. So wherever you see this color, right, this is keyword, and wherever you see this black color, these are whichever the name you are comfortable, you can make it. Okay, so why I am taking EMP-ID as a number is most of the 99% employee IDs will be in number format only. So I have maintained a number, and the name will be always characters. So I am specifying the string. So when I specify the string, which means here Oliver is there. So here the total characters length is 6 characters length. 1, 2, 3, 4, 5, 6. And the Catherine is 1, 2, 3, 4, 5, 6, 7. And this is 4 characters. So when I specify a string, what will happen is it will automatically allocate the memory based on the characters. So for 6 characters, accordingly they will allocate the memory. For 7 characters, accordingly it will allocate the memory. There is no restriction here. Okay. And this insert into the table. So these are the records we are trying to insert in. And we are writing a select query. This select statement is something like we are selecting these column names from the table EMP. So when the moment we execute the select statement, then it will directly go and hit the data storage layer. Okay, so here if you are trying to running any select query, virtual warehouse is mandatory, which means this is the processor. Without processor we cannot run anything, right? So same also here. So virtual warehouse is mandatory, and the database. So already the database by default DemoDB is the default database, so we are using the same database only. So when the moment we choose the database, by default schema will be public schema. Clear? Any doubts here? And if I click the history, okay, now I'm clicking the history. So in the history, everything we will get it. Okay, so query ID. So query ID is it plays a key role. So whatever the operation which we are performing, that will be you can track through query ID. So today, so here you will get the start time and end time. Okay, this is the first. If I click on query ID, so it will take you into the detailed page. So this is the create table. So when we are creating this table, so this is the query, it got created. So the status also will get table emp created successfully. Okay, in the detailedly you will get it. Okay, so this is the status is an error. So the error, the reason is SQL compilation error. EMP is already exist. So we are trying to executing same statement, right? So that's why we are getting. So every information it will get registered in the history. Okay.
Mahesh, so here we logged in with the system admin role, right? So
no. Yeah, system admin. Yes.
So like he will be able to see others records as well, right?
This is I'm logging into my ID, right? So AK Reddy. So only my whatever the operations I have performed, those will be tracked. Other users we can't able to.
Okay.
So if your account admin, then you can able to track all users what are the activities they are performing. Okay, so this is I have logged in individually. So whatever the activity which I am performing with my login, so those all everything will be captured in the history.
Okay.
Okay, so here if I select this query, select this query ID. So if you see here, the warehouse size is extra small. So after that I executed multiple times, but they didn't consider warehouse size, because when we are trying to running a query for the first time, this is inserting, right? So we are trying to inserting a data into Snowflake data warehouse. So that cases they will use the virtual warehouse size. Okay, so the select statement is right. So when I'm trying to viewing the data, which is already stored in Snowflake data warehouse, so that case it will use the virtual warehouse name, which means extra small they will take. So if I re-execute the same query again, then it will not go and hit the Snowflake database. It will query result, it will be reused it. Okay, so if you want to view the SQL text, so everything you will get it. So here it will not use the warehouse sizes, as well as it won't hit the Snowflake database. So the query result reused. If you click on profile, query result reused, which means wherever you see query result reuse, for that Snowflake will not charge anything. You can execute a number of times.
So if we alter or if we insert any new records into the table, if you rerun the query, it will hit or like it will reuse.
No. It will hit to Snowflake data warehouse.
Okay.
So when we execute the select query for the first time, so this is how the history will be. So the most expensive nodes will be result and table scan. So it will go to data storage layer and it will choose the table name. See, this is database name demo underscore db, and schema name is public and the table name is emp. Okay, and the result. So once it retrieve the data from Snowflake database, so these are the table name dot empid is the column name and table name dot name is the column name. These two are the column names. So here by looking at the diagram you can understand that. So we are trying to retrieving two columns data from emp table, okay, for the first time. So if you execute the same query again, then it will be query result reuse. This is a caching. So when we execute the query for the first time, it will go and hit the data storage layer, and that data storage layer it will store in the query result cache and it will stay there for 24 hours. Okay, so that I'll give you in detail, don't worry. Okay, and it will show you. So if you execute the same query again and again, then the query result cache will be used it. But Snowflake will charge for one time execution only. If you execute 100 times, still Snowflake will charge one time only. Clear? Any doubts here? Okay. So here every query has its own query ID. Okay. So for inserting, we need a query ID. For creating a table, we have a different query. If you re-execute the same query also, we have a different query ID. Okay. So which means every query has its own query ID. So by using the query ID or by clicking the query ID, it will take you into the high level profile page where we can get the detailed information. So like if I click here, it will take you into the high level profile page and the details saying that whether the status is success and who executed, which warehouse it is taken, and start time and end time, the total duration. Okay, so every information you will get it here. Okay, so I have already specified here. Okay, and here the limitation here is select emp id name from emp. So I have not added comma, I have missed it. So before executing this statement, we don't have a concept called compilation check in Snowflake. So which means before execution, we cannot check the syntax check. We have to manually verify it. So there is no syntax check here. This is the limitation in Snowflake. And another thing is, if I have a series of queries, I have 3 select statement. I want to execute this select statement. So here, if I run it, sorry, if I run it, what will happen is the first statement is executed successfully. The second statement, it is saying that error. Okay, saying that the comma is missed. If I add the comma, if I select it again, and third select statement is wrong because star after that I have added a comma. Okay, if I run it, two statement executed successfully, and the last select statement went an error. Okay. So here what we observe here is, if we have a series of queries to be executed, before execution we don't have compilation check or error check. So the only way to catch the syntax check error here is, we have to wait for the query to be failed to fix the syntax check. This is the limitation in Snowflake. Clear? So I have already specified here. And the next one is, so when the moment we execute the select statement, so this is the result it will appear. So here we have option called download. So if we click download, so we having two formats: table separated value, comma separated value. Table separated value is Notepad and CSV is Excel. Okay. Export, you will get the data in CSV format. Okay. Snowflake support CSV format only. Excel, .excel, XLSX, those formats won't support. Okay, so this is how the data it will be. So we can download up to 16 MB of data from the download tab. So what will happen if the data having more than 16 MB? In that cases, we have to download the data from SnowSQL. So that I will show you in upcoming classes. Okay. And this is the Snowflake architecture. And so Snowflake layers or Snowflake architecture, both are same only. So we having three layers in Snowflake: data storage layer, query processing layer or virtual warehouse layer, cloud services layer or management layer. Okay, these three are the layers. Okay, so the data storage layer, what will happen is, this data storage layer will store all the tables data, which means we have created a EMP table, right? Employee table. So whatever the data we are trying to insert in, the data it will get stored in data storage layer. So which means this layer stores all the tables data and query result. Okay, so in case if the Snowflake is hosted on AWS, which means, so when we are trying to creating a Snowflake account, think same email ID it won't take. So here is the right. So when this data storage layer, what we will do is, in case if we hosted a Snowflake on AWS, then the data and the complete query results it will get stored in AWS only. In case if I use GCP, then the complete data it will get stored resides in the GCP, same as Azure also. Okay. And the virtual warehouse layer or query processing, both are same only. So this layer will handle the query execution. So here if you are trying to running any select query, any statement, select or insert or creation, whatever it is, any step, any statement, if you want to execute it, then we need virtual warehouse, means sizes. Virtual warehouse, which is nothing but a processor. So without a warehouse size, we can't run statement, which means this layer handles, this query processing layer will handles query execution and DML operations. DML operations, which means delete, insert, update operations, will perform within the virtual machines. So this also we will call it as a muzzle of the Snowflake. Okay, this cloud services is there, right? This cloud services, it's a collection of services. So whatever the queries we are trying to executing, for example, I'm trying to inserting this insert values. Okay, some other people also trying to inserting some values into the same EMP table. So whoever executed this insert statement first time, so until my operations are inserted, which means this execution of the statement, once it is completed, then only the second person, whoever is trying to inserting or updating or deleting, his operation will perform. Till the time his execution of the query will be on hold status in the backend. Okay, until unless my execution of the transaction should be completed. Okay, those controlling things will be handled in the cloud services layer. Okay, it's a collection of services, and it will manage all the virtual warehouses execution, which means the processing, and it will manage authentication and access control, which means, as I said, whoever is trying to performing same table on different operations, and whoever is trying to performing operations for the first time, or his transactions must be completed. Until unless other people can't be perform their operations. So those controlling things will be handled in the cloud services layer. Okay, the query optimization, metadata, security, transactions, so everything will be handled in the cloud services layer. So I can say this as a brain of the Snowflake. Okay, it will control everything in the cloud services layer only. Clear? Any doubts here? Don't worry, I already given the notes, so you can directly make a note here. Okay. So in the interview, so many people will expect what is shared disk and what is the this is in the traditional databases, how it was defined, and what are the challenges is facing in the traditional databases like Oracle, Teradata, etc. Okay, so if you see this diagram, so in this diagram, this is one database, and this is a different disk. So it will be having one disk, shared disk, and the different nodes, and it is accessing by multiple nodes. Every node is trying to reading the data from shared disk at the same time, and different other nodes also is trying to writing the same data onto shared disk. Okay, so this node person is trying to reading the data from shared disk from the same table, same data. This different nodes is trying to writing some information, which means writing in the sense inserting the information, updating the information. And at the same time, other node is trying to deleting the data. Okay, so same table, three different persons is trying to performing different operations. Okay, so for shared disk, it is really difficult to manage which person is requesting for what and how it has to manage. It takes some time. It takes a lot of time to manage it for shared disk level. Which means that the data, whatever where the person is requesting, it may not be 100% accurate. Because when the number of nodes increases, here the 3 nodes, what will happen if the number of nodes increases? It is really difficult for the database to access the data which is available in the shared disk, right? So it will be a bottleneck of communication. Communication in the sense each and every node is trying to connecting to shared disk to perform their own operations. And we may not get the 100% sure how the data accuracy will be. Okay, so these are the challenges which they are facing initially in the Oracle databases with respect to this kind of architecture. So the scalability is limited, which means when the number of nodes increases, then it is really difficult for the database to manage all the requests which is coming from the nodes. And another problem here is if two or more than two database nodes are trying to reading and writing at the same time, then it is really difficult for the disk to maintain the data in proper manner. Okay, and the communication it will be really difficult for each and every disk. Okay, so here, so the best example here is if 10 people are working on different work, and it is allocated for one person to do 10% activity, then it is really difficult for one person to complete 10 people's of work. Correct. So same way here it will also apply it. So to overcome these features, they introduced a shared nothing architecture. So this shared nothing architecture, when they was launched in the market, so everyone they understood it's moreover kind of a revolution. So later they found a lot of issues. We will see. So here is every node they assign for one disk. So here they won't get any problems here. So if a node want to refer a data from this disk, then it will refer the data to this disk. So if whatever the operations which he is trying to performing, then it will be one-to-one, this person to this disk. Okay, but sorry, here this shared disk, whatever in the shared disk, a bottleneck communication common disk, whatever they are facing the issues, that will be completely overcome with this shared nothing architecture. Okay, so to solve this problem in shared nothing architecture, we assign a storage for every compute node. So this compute node to this one. Okay, and the advantages here is the processing and compute together by distributing the data into across the processing nodes. So it moves the data storage closer to the compute so that it won't be any issues here. But then in this shared nothing architecture, few problems arise due to nature of this architecture is what will happen when the data volume increases, the number of nodes will increases, right? So each node is responsible to store the data on the disk. Correct. So if a node want to refer a data from different node, which means, so this node want to refer a data from different node, this node, then here it will start coming up the problems. So if a node want to refer a data from different node, then the data gets shuffled between these nodes, which means the connection should be established between this database to this database. Then only this node want to refer a data from different node, or this node want to refer a data from this node, they can access it. So if this node want to refer a data from this node, or this node want to refer a data from this node, these cases the data should be shuffled between these nodes. Then only the data exchange will happen. Okay, but the problem here is, in case if this node fails, what will happen is, if this node want to refer a data from this node, then the data exchanging, this is already corrupted. So then when the moment referring the data from different node, this will also will get corrupted. If the different node, if he is want to referring the data from this node, then this will also corrupted. So which means it will become, the whole system will be getting down. It will impact the whole performance of the system. So later they realized this is also not up to the mark. So you may get doubt how this organization still they are maintaining. So whenever they want to refer a data from different node, then they will check manually by the admin people whether the complete node is any issues on the node or not. If there is no issues, then only with the special permissions case only they will allow from to refer the data from one node to another node. Clear? Any doubts here? Because this will ask definitely in the interview questions. So what is shared disk, shared nothing architecture, and how this all the features will this disadvantages will overcome in the Snowflake. Okay, so 3 problems with respect to hardware and configuration in hardware in shared nothing architecture is, which means in the hardware and software perspective. So heterogeneous workload and homogeneous hardware, and membership changes, problem with software upgrade. So here the problem here is the heterogeneous workload and homogeneous hardware, which means during the data loading activity, sometimes we will load the bulk data, right? So when we load the bulk data, it will need a quick copy of data in the system, which means the complete data it will get copying into databases. In such cases, we are not utilizing the huge processor sizes, which means small volume of the data we can allowed it. But in case if you are trying bulk volume of the data and we are trying to loading into this shared nothing architecture, what will happen is it may require a more processor size. Company will not go straightly and increase the processor size, right? It will heavily cost to the company. So that cases what they will do is they manually split the data into piece of the files and they will load it into databases, either Oracle or Teradata or whatever it capabilities. Okay, so here the time consuming takes time, and the another problem is membership change. Membership change in the sense, if a node want to refer a data from a different node, then the amount of the database, it will get reshuffled between these nodes. If any node fails, then it will impact the whole performance of the system. Correct. And the third problem here is problem with software upgrades. So during software upgradation or version upgradation or patch upgradation, what will happen is sometimes this node it will version upgrade will happen. This node will version will upgrade happen. This node may not support the version upgrade. So that is the problem, because this is the shared nothing architecture. It is divided each and every node for assigned for one database, right? So it may not at a time, it will not allow us to upgrade the software, version upgrade or patch upgradation. So these cases, what they will do is, whatever the data it was available in this node, they will shift to different node, complete node. Then they will work on the issues, whatever the issues which they are facing, they will fix it. After that, they will upgrade the version upgrade. So it will not be a complete system upgradation, it will be a partially upgradation, step by step they will upgrade it. So this is also challenging. Okay, so here this is the difference between shared disk and shared nothing architecture. In shared disk, quick adaptability to change the workload. So which means the hardware setup cost will be huge in the shared disk by comparing to shared nothing. Okay, thus the software and hardware setup is bit less by comparing to shared disk. And high availability in the sense, the data which we are trying to loading, it will be more redundancy. I cannot say more redundancy, it will be a more duplicate data, it will be available. So manually we have to cleansing the data. And this data node, it will be a single. So each and every node will be connecting to single shared disk. But here every node will have their own compute node. The performance is a bit higher, which means it takes a lot of time whenever we are trying to pulling the data. But in shared nothing architecture, it will take less time. Okay, and the data partitioning will manually has to be done here in the shared disk. But in the shared nothing architecture also, we will do data partitioning manually. But by comparing to shared disk, it will be less work in the data shared nothing architecture. Okay, and to overcome all the problems whatever we faced in shared architecture and shared nothing architecture, in terms of the software, in terms of the hardware setup perspective, and in terms of the volume of the data. So in Snowflake, what we will do is we can load bulk volume of the data. It is very easy to process a huge volume of the data in Snowflake. So all we have to do is we have to write SQL queries, because we don't have to worry about the data backups, query optimization, indexes, and out of memory issues. We will never face these issues. But one thing we have to do, be very cautious while using the Snowflake, that is cost. So keep the cost in mind. So whatever we are doing this activity, before performing the activity, we have to think twice whether this will be add to the cost or not. That's it. So there is no limitation here. You can it is easy to process large volume of the data also. So this is the I can say the impact or the power of Snowflake. Okay, so whatever we discussed till in shared as constrained thing architecture, those all problems will be overcome in Snowflake. So this architecture we will call it as a multi-cluster shared data architecture. Okay. Any doubts so far? So don't worry, I have already given the notes. So it is easy for you guys. Any questions, any doubts, any clarifications? All good? Hello? Guys, can you hear me? Yeah. So I hope everyone is clear. Okay. Move to next topic. In data warehousing, we having a caching concept in warehouse. So here, so the warehouses, so whenever we are executing a query, so the warehouses, whenever we are trying to creating a warehouses, so here the auto suspended is the right. So this auto suspended, if I keep the auto suspended for 5 minutes, which means whenever we are running a query, it is taking more than 5 minutes, then automatically it will cancel the query automatically without human intervention. Okay. And another thing what we observed here is, so without warehouse we cannot run statement. Correct. So warehouse is mandatory. And if the warehouse is auto suspend time limit, if you set 5 minutes, and if I assume if the select statement is taking more than 5 minutes time, then automatically this query will be cancelled in the backend. Okay. And the other point is, always try to avoid select star from queries, because this is not suggestible. Clear? And the next point is during development activity. So which means in the development system, as I said, right? So the auto suspend time limit, it should be maintained minimum 15 minutes during in the development system. Okay, that is suggestible, the auto suspend time limit. So if the person who is working on so I have already created an employee table and I have loaded all the data. If the other person want to refer this data, then share our name, the table name or the warehouse name, so that it will save their time and cost also. So which means share our virtual warehouse when a group of users working on the common table, so that you don't want to create a new table and again you don't want to maintain the data. So once you maintain the data, and if you feel this data is really helpful for other Snowflake developers also, then you can just drop an email to saying that I have created a table and so on, so data is maintained in this table. Whoever want, you can refer this table, so that it will help to everyone in the team. Clear? and this reusing the query results in Snowflake is completely free, which means when I execute the query for the first time, then Snowflake will charge for that. So if I execute the same query again and again, then Snowflake will not charge for that. It is free of cost only. So when it will free of cost is so today at 8:10 a.m. I have executed statement select star from EMP. Okay. So what will happen is when I execute the query for the first time, then it will go and hit the data storage layer. And it will show the result. So how Snowflake will charge here is which virtual warehouse you used. Okay. Size, I can say virtual warehouse size. Based on that, Snowflake will charge for that. Okay. And if I execute at 10 a.m., same select statement. Here, it won't go and hit the data storage layer. It will use the query which is already used, right? Query result reused. Okay. So here, virtual warehouse size not required. When it is required, in case at 5 p.m. I have made some changes or inserted records and I have write a select statement, select star from EMP. So what will happen in this case? It will go and hit the data storage layer. So Snowflake intelligently maintain the data. So in the cloud services layer, will verify this all the activities. Okay, it will go and hit the data storage layer. It required here virtual warehouse size. So manually, we are not intimating or informing to Snowflake data warehouse everything. Snowflake will understood that. So here it will be charged. Okay. If no operations performed, then the query result will stay there for 24 hours. Okay. So here one catch here what we observe is in case I'm working on 100 billions of data and this is and the user is trying to looking this data in every daily basis or every weekly basis or every alternate day. So that case, when we run this 100 billions of data in the production system, Snowflake will charge for that. Based on the volume of the data, Snowflake will charge accordingly. Okay, here is chargeable. What I'll do is, if this data, whatever we are maintaining 100 billions of data table, is not a frequent operation table. Okay, so maybe in a monthly basis, they will do some performance, which means they will do some operations like in